All right, so welcome back to part two of our lesson focusing on tangents and circles. The last lesson, we focused our attention on new terminology that helped us describe common tangents and tangent circles. Today, we will look at two theorems in a corollary that, would combine with our knowledge of right triangles, can be incredibly useful problem-solving tools. So let's get started. Okay, the first theorem that we're going to study states that if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So the diagram kind of illustrates what's going on here. Line AB is tangent to circle Z at point Y. So the radius YZ and that line are going to be are going to form right angles rather at that point of tangency. Now, if we think about that and think about something that we learned a while back, the distance between a point and a line is the length of the perpendicular segment that connects the two. So if we look down here at this diagram, if I draw the center of the circle in, and I draw a segment from the point to that line, that perpendicular segment is the distance between that point and that line. So in this case, that segment that I've drawn in is the radius of the circle. So this kind of gives you a brief little proof of why that theorem works without actually getting into a formal proof. So let's take a look at an example of how this would be helpful. So example number one tells us that line RS is tangent to circle P at point R. It says if PS is equal to 15 and RS is equal to 9, then find PR. So the first thing we'll do here is we will label the diagram with the given information. So we know that PS is equal to 15 units, RS is equal to 9 units, and we're interested in determining PR, which I'm going to call X. Now, based off of the theorem that we just learned, we know that line RS is tangent to circle P and the point of tangency is point R. So that means there's a right angle formed by the radius and the tangent at that point. So really we're just dealing with a right triangle here, and we can use the Pythagorean theorem to determine X, which would give us the length of PR, which is what we're trying to find. So I'm going to set up the Pythagorean theorem. X squared plus 9 squared, so the sum of the squares of the legs, is equal to 15 squared, which is the length of the hypotenuse in this case, squared. So we're going to have x squared plus 9 squared is 81, and that's going to equal 15 squared, which is 225. Subtract 81 from both sides, and we're going to get x squared equals 144. Again, we'll take the square root of both sides, and we're going to get x equals 12. So in this case, the length of PR, this diagram is not to scale, but the length of PR is equal to 12. I'm actually going to cut this video right here and do a separate video for the next part because I think the next two parts go together pretty well. So in the next video, we're going to talk about the converse of the theorem that we just discussed and also a corollary to that converse. And again, those ideas combined with our understanding of right triangles is going to help us solve different types of problems. See you in the next one.